Hi, this is just a quick tutorial on some of the temperature control aspects of the TG40. So today I'm just happen to be running a TG200 which has 5 slots in it, and I have 2 TG40s, one in one slot and one in slot 2. So I'm just going to focus on the TG40 in slot 1, and the first thing I'm going to do is do a new experiment. So test, description, test. I'm going to change my save rate to be 1 every 3 seconds, and then we get to the main part really, right? Relative humidity. What's the humidity of your lab? Let's assume you're air conditioned, so you're about 40%. Let's assume that your temperature in the lab is about 20 degrees. If you have these conditions, then the device can work from 40 to 60 degrees C. If you happen to have a lab that's a little bit cooler, obviously 18 degrees, that now translates to 2 degrees and 58 degrees. So let's just assume that you're at 40 degrees, 20 degrees. Now you have 2 modes of operation. The first mode is have all 5 rows, and so we have 5 temperature zones on the TG40. Row 1 constitutes temperature zone 1, row 2 temperature zone 2, row 3 temperature zone 3, 4 temperature zone 4, 5 temperature zone 5. So into row 1 I'm going to run this unit at let's say 6 degrees, and it populates. It goes 6, 10, 14, 18 and 22. I just want to show you a feature that when you're a long way from the ambient temperature, then the temperature differences between the rows is set to be 4 degrees C. Now let me just show you that in fact if I was working at something like 18 degrees, it would allow me to actually put 18, 19, 20, 21 and 22. And this is just because you're close to ambient at this point, so the unit can do, effectively it has to do less work, so it can do this finer control. But as I say, if you're working a long way from ambient, let's say I'm going to set this at 4 degrees C, then it forces you to do a 4, 8, 12, 16 and 20. And the opposite is true as well if I'm going to work at extreme temperatures. So let me just put something like 58 up here. 58, 54, 50, 46, 32. But then again, if I was going to work at something closer to ambient, 29. If I put in 29 there, I can put in 30. So I'm saying this. You can run all 5 temperature zones at 5 different temperatures. If you're close to the ambient conditions, you have temperature differences of 1 to 4 degrees possible. If you're a long way from ambient, then you get 4, 8, 12, 16, 20 for example. Now that's when you're running at 5 different temperatures. So let's just, standard experiment is 4, 8, 12, 16, 20. But let's say now you actually want to run the whole unit at the same temperature. I kind of call this mode 2 of operation. So what I'm going to do is just click this box here. So what this means is that all 5 temperatures are actually going to be the same now. Again, this is a sort of a power function, because what's happening now is I'm at 20. The lowest temperature I can achieve is 10 degrees away from ambient. So if your ambient temperature is 20, when all 5 rows are set to be at the same temperature, then I can go to 10 degrees. If I happen to be working in a cooler situation, then that number becomes 8 degrees. So I'll assume that I'm at 20 degrees. I want all 5 rows to be the same, and I can do that. I put in 10, and it just populates them with 10. So what have we discussed so far? We have discussed, and I'll go back and we'll just quickly go over it. File, new. We've discussed fill in the ambient conditions, and you have 2 modes of operation. Either run at 5 different temperatures or set all the temperatures to be the same. If you run at 5 different temperatures, if you work far from the ambient, then you'll be having temperature differences are 4 degrees, 4, 8, 12, 16 and 20. Similarly, if I make that 5, 5, 9, 13, 17, 21. If I work extremes, hot, it'll give me 59, 55, 51, 47, 43. If you set all 5 temperature zones to be the same, then your minimum temperature is 10 degrees less than your ambient temperature. So in this case 10 or 50. Okay, so that's when running all 5 at the same temperature. So what I'm going to do is I'll just do a kind of fairly modest experiment today. 8, 12, 16, 20, 24. Next, you can populate, we have 40 wells to play with, so we have 5 temperature zones. You can say what's actually in those particular wells. And then I'm just going to start the experiment. Right, so that experiment's actually running at the moment. And the reason I was starting that experiment was to answer a question regarding ramps. Because the TG40 has kind of 2 general modes. Mode 1, run all 5 rows at different temperatures. Mode 2, run all the zones at the same temperature. We've discussed that already. And then the other really cool thing is the dynamic control of temperature. And we have ramps. So we have ramps that can increase the temperature or decrease the temperature. Just so you know, when you first start the unit, first thing in the morning or in the afternoon, the unit won't allow you to apply a ramp in the first 20 minutes. And the reason it won't do that is it's making the assumption that it's equilibrating. So at the moment this unit has got a set point of, or this row has got a set point of 24 degrees. That was being achieved, so it's got 23.9. This one's got 20 degrees, it's got to 20.1. So you can see very quickly that what it's doing, it's using its resources. And in this particular order, it takes care of row 5 first of all. It takes care of row 4. It's almost taken care of row 3. Now it's just on its way down to 16 degrees C. You can see that number dropping. So it takes about 8 minutes really to equilibrate, but in the software it just assumes 20 minutes. So that's just one note on ramps. You can't do ramps in the first 20 minutes. But then again, you don't have to move your material to the block until it's actually equilibrated. So it's not really a blocker on your work. Okay, so far 24, 20, 16. You can see how quick it is, and now it's taking care of this particular row. Temperature's dropping down. And what it's doing here is graphing. It's kind of grabbing all the data, and it will save that, and you can export that later on, either into comma separated variables or delimited tabs. Now I just want to touch on ramps. The important thing about ramps is we have 5 temperature zones, and they are independent in terms of they can be at 5 different temperatures. But we have a rule running in the background of the software, and the rule is we never want 2 adjacent rows to be more than 4 degrees difference between them. The reason being is we don't want a situation where row 1 is at 4 degrees C and row 2 is at 60 degrees C. You can see the situation, you're going to have a hot next to a cold, and they're basically fighting each other. We can't have that situation, and that's why what I'm about to tell you about ramps, that's the reasoning behind ramps. So what I'm saying to you is, in this example, we have, see that one's almost gone to 12 degrees C now. So we have 5 different temperatures, so they are independent. But if I apply a ramp, it's going to apply it to all of them. So for example, increase temperature by, and I'm going to do a 2 degree ramp over 1 or 2 hours. Yeah, 2 hours. And I'm going to tell it what time to start that. So I'm doing this documentary on the 19th of August 2013. So I'm going to tell it to start this at 10 AM. Actually, I'm going to do that over 5 hours. Right. So what I'm saying to you then is this. I told the unit to ramp up by 2 degrees. to do it over 5 hours, to start at 10 AM this morning, and that is ready to go. And I made sure that I didn't start it. I had to start it at 10 AM because I've given myself plenty of time for this system to equilibrate, because I know that the software won't allow me to do start around 20 minutes after starting the unit. Okay. That's it, so the unit's now going there. Now, just another kind of point about this. I'm gonna at this moment now, I'm gonna disconnect the unit. So, if you see that I have a unit in slot 1, I'm just gonna remove it from the TG200, and you can see it disappears from the software. What's really great about the TG40 is it has a online battery, it has a battery built in, and it has it also has memory on board and a processor, so it actually remembers everything I've told it to do, including these ramps. So you can't see the ramp at the moment because the ramp's actually on the unit, so I'm going to plug the unit back in. And there, the ramp reappears. What I'm saying to you is, when you disconnect the unit, it remembers everything you've told it to do. So these ramps are remembered. So it won't just stop running a ramp. So if I tell it to go up by 2 degrees C, it won't just stop it at 1 degree C. It will carry on doing what it needs to be doing. So I really want to make that point then. Whatever you've told the unit to do here, in terms of set points or ramps, the unit remembers. I'll disconnect the unit. Right, so it's off, it's gone. Bring it back. It's remembered it, and it's remembered that it's got to do that ramp as well. Okay. Well, if you have any questions, contact us at www.centeo.com. Email us at info@centeo.com, and we'll be happy to answer your technical questions regarding the TG40. Okay, take care. Thank you very much. Bye-bye.